Hello, and welcome back to the Rawkode Academy. My name is David. It's been so long since I've done one of these, I've forgotten my own name. My name is David Flanagan, although you may know me as Rawkode. And today we're taking a look at more open source, cloud native, Kubernetes container, all the cool things, technologies. Today we're taking a look at Portainer, and I am joined by co-founder, maintainer, developer, all the hats, Neil Cresswell. Hey man, how's it going?
It's going very good. I'm going to correct you though. I'm definitely not a developer.
Oh no! Oh, my
I,
bad.
I'm definitely not a developer. I am an engineer and a consultant, but I'm definitely not a developer. And to be fair, you don't want me anywhere near code.
All right. Well, apologies for that. Maybe you could give us a little bit of background on yourself then and correct me at the same time.
Sure. So yes, I am the co-founder of Portainer, uh, and I built Portainer to solve a problem that I had a number of years ago, which was how to make the transitional jump from someone managing virtual infrastructure to someone who now needs to manage container-based infrastructure. My entire career has been spent in the infrastructure world. I was an engineer at IBM. I was a consultant at IBM. I was a consultant at VMware. I lived and breathed infrastructure and virtual infrastructure technology. Um, and 7 years ago, VMware themselves opened my eyes to the wonderful power of Docker. And I'm like, this thing is amazing. It's an absolute game changer. But we're going from a very, very mature and well tooled uh, ecosystem around virtual infrastructure. I mean, there were, VMware had the tooling nailed for virtual infrastructure to this new world of containers. And oh my goodness, it was like we've just gone back in time, 10, 15 years there because to me, Docker at the time felt like the early versions of VMware ESX way back in the day. And I'm like, okay, let's not try and have this experience be 10 years and leap and go from nothing to highly adopted. Let's try and create a bit of tooling to help people make that leap, make that jump from being virtual engineers to container engineers. So I built it for me predominantly, and it's gone nuts. I like to tell a story. Anthony, my co-founder, and I, we built this thing. We put it out there, open source, not knowing what that meant, of course. So, because we were using it internally, put it out there. Somehow it got picked up on Hacker News. This was in September. I woke up on Christmas Day 6 years ago, and we had a million downloads of the product. And I'm like, wow,
Wow.
geez, what happened there? Uh, New Year's Day, 10 million downloads. Um, as is the power of open source, as is the power of things like Hacker News' ability to propagate a good story. And from there, it never stopped. I think we're at 3.4 billion downloads of the product over the life now. So it's ridiculous. So there you go. It was a long-winded way of saying hello.
Yeah. Wow, I had no idea just how quickly the growth was. I mean, I definitely remember when Portainer was announced. I don't know if it was the Hacker News, maybe it was a bit longer or a bit shorter after. I have no idea. But when I was going to user groups up and down the UK, it felt like everybody was running Portainer in their house. They were running containers using Portainer as a UI. Like, I imagine it spread pretty much like wildfire. I mean, 10 million downloads in what, the space of a week or 2 weeks is that's wild.
It's nuts. Yeah, it
Yeah.
was nuts. And at that stage, it was just two of us, and we seemingly became the de facto Docker help desk. And so, yeah, our internal communications, everything else, we spent so much time. This was kind of a side hack, right? And so we
Yeah.
were spending so much time answering questions because we were spending a lot of time understanding the technology. And so we were able to answer questions pretty rapid fire, problem, solution, problem, solution, problem, solution. So
You kind of addressed this, but I'm going to ask it and see if we can get a bit more detail. Like you said that the technology containers, it felt like you went back 10 years, you were used to this very, I don't know, VMware with lots of tooling environment where things maybe just worked or were easier. But was there a specific need that you were trying to solve with a container as you were adopting containers, you and Anthony? Like what was the drive? What pushed you into building this new tool?
I've always described, and I still describe it to this day because I don't think much has changed. I mean, there's more tooling now, but in fact, it's more complicated in my view because there's now so many tools to choose from. But I've always said a Docker host or a Kubernetes cluster, it's just very raw, right? A Docker host is like in VMware speak an ESXi host. A Kubernetes cluster is like a vSphere cluster. You would never in a million years go into mission critical production with just a bare metal ESXi host, and very few people would go into mission critical production with just a VMware cluster. You would have vCenter around the side to help you with managing it. You'd have you'd have something like Veeam or some other tooling to give you backups. You'd have probably a product like SRM to give you DR replication or DR failover. You'd have things like VMware vRealize to give you insights into your application. And one of the important things is VMware recognized very early on having a bunch of 100% disparate tools, each with their own UI, was not a recipe for success. And that's why you find inside vCenter, they added all of the plugins and they let you bring everything together. So from within the vCenter screen, you could configure things like your NSX storage, your vSAN, your NSX networking, your vSAN storage, all of your observability, everything else you could do from within the one tool because they realized that was the way. And one of the things I saw in the container ecosystem was, one, at the time, there was no tooling. There was just nothing. There was just the raw Docker and raw Kubernetes. Over time, and we still see it now, go log into the CNCF landscape. There's a bunch of disparate tooling, but it's disparate tooling. There's nothing stitching all that tooling together into a single experience that makes it really easy for someone to jump in and actually manage everything. And my whole ethos in life is remove complexity. Complexity causes issues. It just does. And I hate complexity with an absolute passion. And so I try to remove complexities, and I do that by pulling tooling together into one place. That's why in Portainer you've got GitOps, you've got UI interfacing, you've got policy engines, you've got everything you can imagine, because I just hate the idea that you have to go out into a bunch of separate disparate tools to achieve what you should be able to achieve within one tool.
Nice. So would it be fair to surmise that as Portainer is your single pane of glass for containers and Kubernetes? Is that your mission? Is that the goal?
It is. A single pane of glass is massively overused. I prefer I prefer the term manager of managers. So yeah, we like to be, or to use Lord of the Rings, we want to be the one tool to rule them all, kind of thing. So we want to be this one piece of tooling that your internal staff have to learn. So you learn Portainer, and by the way, Portainer is very intuitive. There's no need to be certified in Portainer because you just don't need to be. It's so intuitive. And so once people get a taste of Portainer, they don't need to use anything else. I mean, you could if you wanted to. We don't lock you in. If you want to go use other tooling alongside us, feel free. But what we say is for 80% of organizations, Portainer's native capability is enough.
Nice. You've already mentioned a bunch of features that I had no idea existed in Portainer. Like you said, GitOps. Like I had no idea there was that kind of level to it. And I seen something on your blog that I thought was quite interesting too about being a management platform for Kubernetes. But it sounds to me like Portainer has kind of evolved greatly over the last number of years. I'm kind of excited to what we're going to see now today, because Portainer was, the UI, I say, go run this container for me. It does it. And I'm like, cool, awesome. But, it has evolved a lot then, right? So you want to maybe share a bit more details on what that's been like for the last couple of years?
You have no idea how hard it is to actually change people's perception of a brand that's been around a while. I genuinely believe it might have been easier for me to have stopped using the brand Portainer, kept the same product, simply change the name to something else, and we would have been some cool new application out there on the market. If you ask people about Portainer, they'll almost always respond with what we were 3 years ago. In the last 2 years, we've spent over $10 million re-engineering the product to be this Kubernetes, in fact, universal management platform. So Kubernetes, Docker Swarm, of course, Nomad, any Kubernetes, any cloud, anywhere, laptop, data center, edge, anything. It's this universal management tool set that just simply says if you are dealing in containers, then Portainer is the tool that you need to get your applications developed fast, into production fast, safe, secure. That's it. So, right. So yes, there's a GitOps engine built in. There's basic observability built in, so you can see what your application's doing. You can see if things are up or down. You can see the events. We make it really, really easy to discover what's going on in your environment. One of the big things, right? If you don't know the commands to type in, then you can't type in the commands. So if you don't know Kubernetes can do something, then you don't know the command to do that something, then you're ignorant to the fact that there is this amazing piece of capability. Portainer makes it blatantly obvious because there's a button that says show this, and what's this do? I'll click this, and now you've just discovered a new piece of native capability of Kubernetes or Docker. So we make it really, really easy to explore what's there.
Yeah. I'm assuming, and you can correct me if I'm wrong, but the 10 million that you've invested did not come from $1 from 3.5 billion people that downloaded it. So I'm assuming the enterprise business is quite successful. Like, people now are taking Portainer and shipping real production applications. Is that correct?
We are VC backed, so the money comes from VC companies who believe in our vision and believe that there is a commercial demand for our Portainer Business Edition variant, and that the uptake of that is growing nicely. So absolutely, there is definitely demand for people who want to take what's available in the free version and expand on it. We've expanded a lot in regards to policy and controls and security and governance and all sorts of things. We built off the free version and sell a commercial version out there for those who want more than what's in the free version. The free version is still very feature rich, by the way, and we've got roughly 700,000 users who use the free version every single month. They log in and do something every single month. So there's a quite a big loyal global following of the free version. But the free version isn't really enough when you get beyond one team using it. You want a bit more governance and control. So that's where the business edition now comes in.
Yeah, that's amazing. That's awesome. That's exciting to hear as well. Like, I speak to a lot of people that are struggling with Kubernetes. A lot of people ask me for advice, they want help. And I'm actually seeing this trend now where people just don't actually want Kubernetes. They want a platform to run their containers. And it feels like Portainer should just be that option that I'm giving to people. It should be like, look, there's the UI, there's the GitOps operator, go do it. So I'm going to just let you hand over to the screen share and show me some awesome things with Portainer if you're ready to go.
I am. So you're right. Portainer's goal is to try and make the underlying technology irrelevant, because at the end of the day, it kind of is irrelevant. It kind of is. You actually want your application live. The business that employs you as a developer, or the business that employs you as an ops person, or whatever role that you want to be in, the business that employs you doesn't really care about the tech. That's unless, of course, you Google or whatever else, right? But most organizations, they don't care about the tech. What they want is a highly available system that delivers digital applications to market. That's what they care about. They don't care about the tech. We as techies care about the tech, but the business doesn't. But more and more often now, people are saying, you know what, the tech is actually causing me headaches. It's a little bit too complicated for some use cases. I really want to try and divorce myself from as more of the tech as I can. There's of course still a subset of people who just love the tech because the tech is good fun to play with. That doesn't necessarily help the businesses that employs them grow. So we're trying to say, for those organizations who just want to use the damn thing, Portainer is right for you. If you're one of those organizations or one of those people who really, really wants to get in there and turn every dial and flick every switch, Portainer probably isn't for you. So we're a bit more honest and direct and clear with our ideal user. A raw expert who wants to be able to flick every dial and turn every switch is not. Portainer abstracts away with the goal of making it really easy to consume.
Yeah, I consider myself a bit of an expert, but I also think that I'm so done of fiddling knobs and playing with switches. I think I just want things to work now. I don't know if that's just me getting older or not, or tired, perhaps. But yeah.
I am very salty. I have run I've run mission critical cloud services. I was CEO of a public cloud provider. One of the worst things to happen is an outage. You know, everyone has outages, and anyone who says they don't have outages is lying or hasn't yet had one. But outages happen at 3 in the morning when there's an outage. You want to be able to pick up the phone and say who can get in here and help me right now. And if it's one person, because only one person has the actual depth of knowledge of the platform, man, you're in trouble. You want to be able to get 15, 20, 100 people, everyone in IT, wake up and get in here now, and everyone in there can roll up their sleeves and get in there and try and solve the problem. If you have a piece of infrastructure or a platform that's so complicated only one person or two people can support it, man, you're in trouble. You really are. And I had that lived experience. I had this beautiful public cloud, and I had problems with my underlying storage platform. It was beautifully engineered, but very difficult to triage and troubleshoot. And so I'm like, man, once we got out of that outage, it's like, okay, I need to make this thing way easier. I've got to take away complexity so that I've got more ready access to people who can help me triage and solve problems.
Awesome.
So you will see lived scars, experience, blood, sweat, and tears all throughout Portainer, because I've experienced those. I'm old enough to have lived through all of that pain and suffering, and I'm trying to stop other people having to live through it too.
Awesome. All right, we got a couple of comments I'll tackle just now. So we got one from Russell saying, referring back to your Lord of the Rings quote, but Portainer is Sauron's tool for managing container systems. So there you go.
Cool.
And we have a question for our brilliant guest. Nicely phrased, Murat. How can I not ask that question now? But they want to know about the future of container platforms and whether maybe something's going to replace containers. And they mentioned LXC, Podman, Kata containers. I mean, do you have any thoughts on what comes next? Or do you think, Linux containers are just perfect?
They're all still containers. Yeah, but Podman is just, in speech marks, a fork of Docker. For whatever reason, Red Hat decided that the direction Docker was taking was the wrong direction, so they forked, or it's basically built off Moby, and it's their own thing. So yeah, Podman is very, very compatible to Docker, so it's still the same underlying tech. They're all based off the same underlying principles. Even Containerd from Kubernetes, it's the same underlying thing. Now, LXC containers are somewhat different. Containers in general, I think, are quite universal. Is there going to be a new version, a better version, a more secure version? 100% sure. Containers today are still a little bit too Wild West, if you ask me. Without a bunch of external controls, a container can be used to take complete control of the underlying platform. I'm just going to, while I've got my screen share up, I'll show you what I mean here.
Yep, let me just push that over. There you go.
So, like, for example, here, in Portainer, we let you set some Docker security settings here, because there are certain things, containers will let you do things that are actually dumb. They're actually really, really dumb. Like, for example, I can spin up a container that bind mounts the root file system. No, that's a terrible idea. So we, in Portainer, we actually let you say, well, hang on a second, because Portainer sits between your users and the underlying infrastructure, we're going to disallow, and we basically intercept requests for bind mounts and say, not allowed. Like you can actually ask a container to run in the host PID namespace, and then once you're in the host PID, you can do anything on the host. That's a dumb idea, terrible idea. So block that too. So that same thing with device maps. You can actually say map device /dev/hd0 or sd0 to a container, and then you can do fdisk in a container and erase the hard disk. That's a terrible idea. So all that stuff we basically saying we got to intercept that and block it. Now things like Podman and even Docker rootless mode now can run in a way that they don't have root access to the host. So some of this is starting to be mitigated, but more and more often now, I think we're going to be crying out for a more secure version of containers, the next generation of containers. But from a end consumer or an end user point of view, I think you find things like serverless containers become more and more popular. Things like Cloud Run, or the older and slightly less popular Azure ACI, where you just simply ask the system, here is my container, here are the SLAs that I want you to run this container within, go run it for me, and the platform takes care of it. I think you're going to see that kind of thing take off a bit more, where you simply say, "Hey, I want this container to deliver response times to my users of below X milliseconds." The system says, "Okay, I'm seeing a bit more load. I need to add more replicas. I'm going to go ahead and do that." You shouldn't have to say, "I want 3 replicas and turn on auto scaling, and here are the criteria for auto scaling." The system should be able to determine that from SLAs. And I think that's kind of the future as we mature. And if you look at Google Cloud Run, this is a very nice first version of that.
Yeah, definitely. All right, I hope that helps, Marat. Russell suggested maybe WebAssembly could be a future technology there. And I think Firecracker falls into that too. But we have such an ecosystem,
Yeah,
such a community around containers and so much tooling that I think containers have got a lot of life left in them yet.
yeah. Wasm at the edge, or Wasm, however you want to pronounce it. I've got a crazy Kiwi accent, so um, yeah, Wasm at the edge. I think definitely has potential. This whole assembly on demand, I think, has potential at the edge. Uh, for some reason, Kubernetes at the edge is getting a lot of love. Kubernetes at the edge is very overweight. It's
Definitely.
very hard to use Kubernetes at the edge unless you have a relatively large node. I actually produced a blog just recently where I actually benchmarked all of the nano or micro Kubernetes distros out there to say, can they run on a device with 1 gig of RAM? The answer is absolutely not. Well, they run, but you can't do anything. The moment you try and start even a basic Nginx container, the whole thing implodes. So you can't. Whereas Docker, Podman, and Nomad are perfectly adequate. They need near nothing at the edge. So um, until much larger hardware starts to propagate the PLC and the edge device retailers, and no, a Raspberry Pi is not everywhere. So we're talking about the multi-billion-dollar PLC vendors out there that we all know that run industry. Until the hardware propagates down to that level, we're still very, very limited in resource, and so there's still a real focus on how do I, as an operating system, as an operating platform, use as little resources as possible so there's more resources for applications.
Sweet. Awesome. Thank you for sharing.
I have very strong opinions on Kubernetes at the edge just because it seems like we're forcing a technology into a use case where it doesn't naturally make sense, but we're trying to tell ourselves it does.
Yeah, there's
Anyway,
yeah, I mean, we've seen. I'm assuming I haven't read your blog post, but I'll find it and I'll put a link to it in the show notes for anyone that's watching. But I'm assuming the ones you tested there were like K0s and KCS, and these are the ones that claim to be kind of edge compatible Kubernetes distributions. But
correct,
yeah,
and a spoiler alert: they all need greater than 700 meg of RAM to even idle. So and if you've only got a gig of RAM, 700 meg of RAM used up just to idle. In all honesty, once you get around 900 meg of RAM, then the kernel starts blowing up anyway. There's really no RAM to do anything. So
yeah, no room for the
they,
workloads at all. So you're just
there's no room for
saturated
the
at all.
workloads. Yeah, and most far edge, or true edge, as I like to call it, devices, they are still ARM, maybe ARM 64, but almost always they're a single CPU. If you're lucky, maybe a quad core, but it's a quad core low throughput CPU, 1 gig of RAM, 2 gig of RAM, really. So you're still very limited. Now I understand that there's the edge. Edge is a very large use case. You've got network edge, which are servers. You've got edge gateways, which are far larger i7s with 8 gig of RAM and mini clusters. Those ones are fine, but true edge, far edge, IoT type use cases, very, very limited hardware resource.
All right. Let's jump over to your. Are you starting with Portainer? Are you doing some slides first? How are we doing this?
I can do anything. I have some slides that I can run through if we like. I literally just shared these slides last night. I built them just for this session. Um, I can run through these things at a blistering pace and then go and show you live.
Well, yeah, you
Our
built
whole
them. It'd be a
thing,
shame not to show them. Come on.
it would be. Um, Containers, managing containers shouldn't be hard. And unfortunately, it is hard. And anyone who says it's not hard either hasn't gone deep enough yet, it's not fully in production, or they are absolute ninjas and are able to comprehend the complexity. But for the average IT person, managing containers is far harder than it needs to be. And so our whole ethos is it shouldn't be hard. We like to sit in the middle and be this universal tool set. We don't care where you run Kubernetes. If you run Kubernetes in any of the cloud provider managed Kubernetes offerings, we don't care if you run Kubernetes on-prem. We don't care even if you don't run Kubernetes and you run Docker or Podman. For us, it doesn't matter. What we care about is helping you get your container-based application into production in a safe and secure way. And our whole ethos is for those organizations that are just getting started, we want to help them. I have many times described Portainer as a tool that enables the have-nots to compete with the haves. And what I mean by that is there are a bunch of organizations, the have-nots, who don't have the financial ability to go and invest in highly skilled experts to support Kubernetes. They don't have the ability to go and invest large sums of money in very expensive enterprise products like OpenShift potentially to try and offset. So these have-nots still need to try and compete against their much larger competitor organizations, and our goal is to try and enable them to succeed. So another way I like to describe us is we are the Robin Hood of cloud native.
I like that.
So we describe ourselves as a container management platform, and a container management platform is something that lets you manage all of these componentries. They let you manage the orchestrator. They give the ability to get observability of the systems. They let you see the logs. There's a CI/CD engine. They let you better manage the networking, service discovery. All of these things need to be addressed in some way by the container management platform, because like it or not, you actually need one. Now you can go and choose to build one yourself, and this is the CNCF eye chart. I think last time I checked, it was actually an A1 printout. I think it may even now be an A0. So, you as an engineer or the company that employs you needs to make a decision to go and build a management platform. You will need one. If you just think that you're going to go Kubernetes or raw Docker, you're solely mistaken. You absolutely will need a management platform. Now, you will either go and build one yourself. You'll go and get Argo CD. You'll probably go and get Prometheus and Grafana. You'll probably go and get some HashiCorp Vault. You go and get a whole bunch of these products, and you'll assemble yourself a management platform. You've just built yourself an ongoing maintenance nightmare. Now you need to make sure that all of these products, well, for a start, you need to make sure the products that you've chosen actually have life in them. So they're being actively developed. They're well funded. They're not going to vanish tomorrow because you're going to have to replace them. But then you need to make sure that they are interoperable with each other, that they're interoperable with the version of Kubernetes or Docker that you're running, and you have to maintain and patch them as a cohesive unit. You've now created a maintenance overhead to manage this platform. So you can do that, or you can choose Portainer. That's kind of where we're at with this thing. Why skilled labor shortages? If you go look at any CNCF survey, what are the barriers to adoption? It's pretty much these 6. It's very hard to find people. When you do find them, they're eye-wateringly expensive. It takes a long time for people to come up to speed with containers in general. Things like Kubernetes, they're not secure. I'm not going to use the term insecure by default because that has negative connotations, but they are not secured by default. They expect you to know what you're doing to secure them. You have to go in and lock them down. They're not locked by default. You have to lock them down. If you don't know what you're doing, the platform's insecure. There's so many examples or surveys that have been taken where completely open Kubernetes clusters are exposed to the internet because people just didn't realize they have to lock it down. Things like Kubernetes RBAC, it's pretty easy to actually configure users and roles for one cluster. You can go and manually create users. You can go and manually create roles and role bindings, but that's one cluster. When you've got 20 clusters or 30 clusters or 200 clusters, oh my God, to do that across that, now they need a tool like Okta or something else to try and take care of all of the federated user identity and how you can do all the RBAC management. So that's tricky. Data operations, again, if you don't know the commands to go and triage to view the events, you really are struggling. So we want to try and make that easier. And providing secure access to the environment. A lot of people say the only safe way to give a developer access to Kubernetes is to not give a developer access to Kubernetes. Really? How then are they supposed to triage their application in production? Really, you want to give them secure access. Now, the reason a lot of people don't give dev access is because it's actually quite hard to go and configure the roles and role bindings successfully so that they don't have accidental too many writes. So they're the main 6 reasons. We have 3 now. I've called them product variants, but you could actually think of these as use cases. It's actually the same product; they're just different use cases. So Portainer, it being used as a universal management platform. If you have the need to manage Docker on your local machine, maybe you've got some Docker Swarm because you've got some legacy environments or whatever. You've got some Kubernetes, maybe you've got some Nomad. Then Portainer as a single platform can do all of that. Maybe you're all in on Kubernetes, but you want a way to centrally manage Kubernetes. No problem, we can do that for you as well. Or maybe you're actually got a really large edge use case, IIoT, or an IoT type use case, network edge, call it what you like, smart city. Portainer is very, very strong in the edge management as well. So we have 3 distinct use cases. We're calling them three different variants of the product. It's the same product under the cover, so you don't choose one and then you're locked in. It's the same base product, but and again, at a nutshell, the main benefit of Portainer is to facilitate the transition from VMware or VMs into containers. We help you or help your team with that mental transition by giving familiar tooling. It's a familiar experience. We make it really easy to see what's possible with the tech. It's very easy to discover capability because there's a button that does something, and you're like, oh, what's this button do? And so you now realize that there's actually some underlying capability that's amazing. And the time to learn Portainer is very, very, very short. I was talking to somebody just recently who said they spent 2 weeks looking at one of our competitor products and hadn't really got it working. And he said within 5 minutes, he had Portainer up and running, integrated with his Active Directory. He'd configured a couple of clusters and he had RBAC running. I was like, yeah, that's pretty cool. That's what we want to do. So, we want, once you get going real quickly. So get you going fast. Kubernetes, multi-cluster management, really simple, no lock-in. Portainer just works with any Kubernetes API. We help you secure the environment through policies and controls. We make it really easy to triage, and it's very easy to drive Portainer. Edge, massive scale. A single instance of Portainer can actually manage 45,000 remote environments, and we are scaling that. The target is 100,000 by sort of middle of next year, and we're going to keep scaling beyond that. So you can actually add, a lot of clusters or a lot of individual nodes. Because we've designed Portainer to be easy to understand, OT engineers, which are systems engineers in industry, it's easy for them to understand. We have things like device management as well. We've got integrations with Intel AMT for lights out. That's like a BMC card for server people. Zero-touch device onboarding. Portainer is self-hosted, so we can run safely behind your firewall. You don't have to give the keys to your kingdom to some SaaS service. It's all inside your firewall. Portainer needs about 20 meg of memory to run, so it's really efficient. So naturally works well in an edge. And we have a lot of async controls, API controls. So we actually work really well over networks that are highly latent or unreliable. And our goal is basically to make things really, really easy, really easy. You don't have to try and remember all of the command line. You don't have to try and know how to write YAML. I mean, if you want to write YAML, go ahead. We can help you do that with our GitOps engine. But if you don't want to, you don't have to. There's a UI. Yeah, there's a UI that will do it all for you. Makes it nice and easy. G2 says we're awesome, and so because G2 says we're awesome, I say we're awesome. G2, unlike Gartner, is actually something that's done by the community. So the community votes and ranks it rather than a independent company like Gartner basically saying you are where you are. G2 is actually crowdsourced, and people go and actually submit votes and comments and vote for who they believe and where they should be. So this is actually direct feedback from our users. We are really the only tool that spans every cloud provider every Kubernetes, Docker, serverless even. So, if you have a very hybrid world, we're the only tool of choice for that. And we're really the only tool that can go from data center to edge to my laptop to cloud, any cloud. So it's very, very flexible in that regards. Portainer sits in between your users and the platform. So when you deploy Portainer, users interface with Portainer. They don't interface with the underlying platform anymore. So it's very good because it means that you don't have to expose your Kubernetes APIs externally. Portainer takes over and is the API endpoint for your users to interface with. So if they're using third-party tools, maybe like OpenLens or kubectl or the Azure, the Azure DevOps tooling or anything like that wants to talk to an API, it can talk to Portainer, and Portainer will proxy that to the back end based on relevant permissions. That means that you can really lock down API access to your clusters in the back end. So we sit in between. We take care of all of the user authentication. We basically provide a safety blanket around all of the environments to make sure that users can't do dumb things. We make it really easy to do hard things, and we make it very hard to do dangerous things. Portainer is said self-hosted, can run multiple things, connect it to your auth. We support OAuth and LDAP, so you can go to any kind of OAuth provider. SSO is built into the product, even in the free version. We don't believe in a SSO tax, so SSO is available. Roles and teams, RBAC, and native proxy. And again, Portainer sits in between everybody and connects through to agents that run in remote environments. So really, really flexible tooling. And I'm not going to go any more on slides. I'm going to actually show you the thing.
Awesome.
Great. Any questions come up through that?
No, I think that was very informative. I had no idea that you actually proxied the Kubernetes API and I could still leverage kind of my, standard tooling. So that was a nice little treat. So now I'm just looking forward to actually seeing the demo and the UI and what we can actually do with it. We got a comment from Eddie just saying, hey, and saying great t-shirt. Although now that we've spoken about the complexity of Kubernetes so much, I may have to hide my Kubernetes t-shirt. I don't
know. Right, yeah, I'm just jumping the command line, but I'll stop doing that at this point in time. So yes, we do. You see, when you log in, I'm logged in as an admin, and you wouldn't normally log in as an admin, so you're seeing more of the UI than you would do, and I could probably log in as a user to show you, but in the interest of time, I won't for now. But here I've got a bunch of Kubernetes environments, and if I click kubeconfig, I can go and generate a kubeconfig file that will allow me to connect to all of these environments. And if I download that file and open it, you'll see here all of the Kubernetes endpoints are actually Portainer. So they're all connecting through. So no matter which cluster I'm talking to, I'm actually talking through. So here I've got a Linode, I've got a Civo, I've got a GKE, I've got a DigitalOcean, I've got an AKS. All of them are actually connecting through to Portainer as the API proxy. So from kubectl on my machine or OpenLens on my machine or whatever other tooling you choose to use on your local machine, then you can connect to these backend clusters through Portainer, and we basically just get in the middle and make sure that the RBAC roles are applied and everything's working just fine. So in that regard, it's nice and easy. So if I come into a cluster, as an example, I'll come into a DigitalOcean cluster. We have the ability, again, I'm an admin, right? So I have God mode access to this environment. I have the ability to create namespaces in here. I can actually say I want to create them from a manifest, so I can link this back to a Git repo and have a Git repo, a GitOps engine, controlling the namespace. Or if I don't want to, I can use our form, and from the form you can go and set things like quotas for the namespace. So you can say, okay, this namespace has this kind of quota. I want to actually say there's a load balancer quota. They can only actually spin up or request 2 load balancers in here. So because load balancers are expensive, I look at our cloud bill every month, and a huge portion of it goes on load balancers. So maybe you want to control that. Do we want people to be able to use the ingress controller? If so, what domain names are allowed? So we might want to say, okay, you can only use these domain names. Are there any registries that we want to give them access to, and we'll propagate the registry credentials? Do we want them to actually have access to persistent storage? If so, how much persistent storage can they assign? So we can go and set all of these things, or we can just do a raw one and say, you know what, there's actually nothing, no restrictions. We're going to create a really, really simple namespace, and off we go. You go and create it. Once you have a namespace, you can actually see, well, who has access to the namespace. So you can see, well, which teams, which users, or which teams have access to that namespace. So it makes it nice and easy to grant access to it. And again, coming back to us trying to be a bit of a guardrail, at a cluster level, we can actually say, you know what, we don't want people to have access to the default namespace. So many people continue to use the default namespace. Don't use the default namespace. When you are deploying applications, put the application in a namespace. Don't use the default namespace. It's just dumb. So we actually say, you know what, as an admin, we're actually going to flick a switch, and then no one can use the default namespace. It's just blocked. If they try to deploy into it, we'll say, not allowed. So that is very good practice and something that we strongly recommend. We even do things like, Kubernetes, because of its infinite flexibility, it doesn't want to say no to anything. So you can have a Kubernetes cluster running on 3 Raspberry Pis, and then a user can ask that cluster, hey, I want to deploy an application. I want that application to have a gig of RAM or 256 gig of RAM. And Kubernetes will say, okay. And then in the background, it'll go and fail because a Raspberry Pi cluster doesn't have 256 gig of RAM. So it'll just fail. It'll sit there in a crash back loop because there's no resource. And the reason Kubernetes lets you do that is because it says, well, if you have auto scaling enabled, node auto scaling, right now you might not have enough resource, but 30 seconds from now, when more nodes have been added to the cluster, you might. So what we'll do is say, fail now, but we'll keep retrying in case you actually add more nodes. If you don't use node auto scaling, then your ability to ever service requests that are beyond the cluster's capability is 0. So we actually let you flick a switch to say, don't let users ask for things that the cluster in its current state can deliver. Again, we're just trying to make it substantially easier for users. So users don't do things that then immediately fail and like, well, it succeeded and now it's failing. What's going wrong? So they're going immediately wasting time triaging, when really they shouldn't be wasting time triaging. We should just stop them doing things that's going to immediately fail because the cluster isn't equipped to deliver it. Same thing like load balancers. Kubernetes, you can ask your micro K8s cluster or whatever else, hey, I want an application, and the application needs to be published with service type load balancer. If you have no load balancer, it'll sit pending forever. Well, it's just dumb. It's going to go back. You're going to go into a triage mode. So we can say, don't use a load balancer. And then if a user asks for a load balancer, we won't let them actually submit the request. We'll say, this cluster has no load balancers. Choose another service type, ingress or something else. So again, we're trying to stop people doing things that we know will immediately fail. Does that make sense?
It does indeed.
Yeah, it's just trying to save time. Again, there's nothing worse than saying yes and then failing immediately, and the user has to go into triage mode. That's just crazy. But also things like constraints here. If you turn on pod constraints, we will go and deploy automatically in the cluster for you. Things like OPA gatekeeper, and here we're setting OPA policies to restrict what users can do in the cluster. Again, trying to stop users doing dangerous things. So you don't have to have OPA, but when you flick the switch and click OK, we'll go and deploy the OPA gatekeeper service for you and configure all these rules for you automatically. So again, We're just trying to make it really, really quick and easy to do relatively complicated things. Like if anyone's configured OPA gatekeeper, it's not easy. So we try and do this for you.
Yeah, I'm just glad you have the toggle button, so I don't have to remember how to write Rego, because I'm terrible at writing Rego.
Yeah, we likely will provide you the ability to upload a YAML file if you already have one that will basically answer boxes for you, like tick boxes for you. Because one of the things that we've been criticized of is that we're not asterisks as code enough. So we will provide the ability to leverage code in the future.
So if somebody really wants to
them.
write YAML to configure Portainer, they can configure Portainer with YAML.
Correct. So we will be iterating that capability. in the future, and more things in Portainer are going to start getting a YAML ability rather than click to enable. But at the moment, we're trying to make things so crazy simple, and the way to make it crazy simple is tick boxes or switches.
Okay. We have a couple of questions if you're happy to tackle them just now.
Go on then.
So Russell is asking if there is a Portainer managed service or whether they run it themselves.
There is not. Everything is run yourself. If there is enough demand for a managed service, then I would consider it. Never say never to a commercial opportunity. There is not currently a managed service, primarily because we don't believe there needs to be. Portainer is so easy to use and so lightweight that we don't believe that there needs to be a managed service. But happy to offer one if there's enough demand for one.
All right. And Russell followed up with a second question and was asking, is there a way to filter all resources attached to an application? So like if we have a pod, can we see that there's a namespace attached, some storage attached, network policies?
Yeah.
Like
So if we come into an application, for example, and I choose one, this test one, you can come in here and you can see here's the pod. If there's persistence, you can see that there's persistence. You can see there's any configurations. You can see there's auto scaling.
Could you zoom in a little bit on that page?
Sure. I forget that I have a terrible font size. Is that better? I'll deploy one, right? So if I do Nginx, and it's just a simple Nginx image, I am going to have an environment variable of foo and bar. It's not going to do anything. I'm going to persist /data. It's going to be 10 gig in size, and it's going to come from this DO block storage. I am going to have one instance, and I could turn on auto scaling if I wanted. I'm going to publish it as a load balancer, port 80, and deploy. So you can see here, we're going to create a service of type, the name Nginx of type load balancer. We're going to create a service called this of type cluster IP. We're going to create a stateful set called Nginx. This is what we're doing behind the scenes for you. You don't know nor care that we've done that, but that's what we've done for you. And deploy. It's going to deploy, and this is going to go and ask DigitalOcean to give me a load balancer. It's going to go and ask DigitalOcean to give me some persistent volume. And now if I come into this application, you'll see here that you can access this through the cluster IP. You can access it through the load balancer. The external IP is still pending, so we've got to wait for DigitalOcean to deliver it. You can see here, here's the configuration. You can see here, here's the data persistence, the container name, the pod name, persistent folder, and here is the back end volume. So we've automatically created the PVC for you and assigned it. It's going to wait to be scaled up. Eventually, you can see the logs. You can go and see all of the metrics information for it. Now, I'll come back and get one that is actually already up. Oh, it's actually already up. Well, I should have just refreshed. I'm just impatient. So you can see here, you can already see the stats. So this is now talking to the Kubernetes metrics server and pulling in metrics around this application. So it's not doing anything, obviously, because it's just a dumb Nginx container. But this is talking to metrics and pulling in some metrics. We can actually come back here and see the application. I can go and get the logs for the application in one place, which does make it easy. And if I need to, I can get a console into that pod and triage that pod if I need to as well. So you're actually in and doing things. So it makes it nice and easy to interface with it. So I don't know if that's answering the question. See here, we're still waiting. Okay, we're still waiting for it. It's pulled the image. It's scaling. You can also see the YAML, by the way, if you care enough about it.
Yeah, I think that does answer the question. We can see all the kind of attached resources. Is there any visual Is there any visual representation? Like a graph, mind map, anything like that? That could be a cool feature.
Absolutely. No, but it's a good feature. By the way, if you come into namespaces, click on the namespace, you can actually see the applications running within the namespace as well. Or if you want another view, you can come to the cluster and you can click on the nodes of the cluster if you wanted to, and you can see the applications that are running on that node as well. So there's a whole bunch of differing views if you want to look at it as well.
Nice.
And again, from the cluster, you can see things, the memory reservation, memory use, CPU. You can see the node stats as well. And again, talking to metric server. So it's a very deep experience. It really is a very deep experience. Again, the volumes. So you can see here that this is the claim that we've created here against the block storage. So here we are here up and running.
Nice.
So it does make it easy. And again, if you really want to, you can click the kubectl shell, and you're actually in that cluster. Kubectl get nodes. You're actually in that cluster inside Portainer, directly engaging with that cluster. Should you want to actually use the command line because there's something you want to do that's beyond what's available in the UI. Should you need to.
Cool.
So pretty easy to go and configure. Like to go and configure a stateful set with a load balancer and a config and that manifest, that Helm file would be quite large. I actually deployed that in a very, very short amount of time. Now, is this infrastructure as code? No. Would you do this in production? Probably not. But for a dev who wants to experiment on their machine, or a dev who just needs to quickly spin things up in a dev cluster, nothing wrong with the UI to get things done quickly. In production, obviously, you would create a manifest file, and you'd use things like a GitOps engine. You configure automatic updates. So you're going to poll Git, look for changes, and force redeploy any changes in the cluster. So in production, you'd use GitOps, but outside of production, ain't nothing wrong with a good old-fashioned UI saving you time. Argue against that. Go on.
No, I'm not arguing about it. I think we definitely need more simplicity in this space. Like, things are wildly complicated. It just
absolutely. I mean, how long would it take you to go write a manifest from scratch? In fact, I can show you the manifest, right? So, how long would it take you to go and write a manifest from scratch that does all the stuff? And unless you're an absolute wizard, or you're starting from one that you already have, and you're just simply copying a manifest and modifying a couple of things, and you really got to be a pretty special. Well, here you go. The load balancer is already up. So there you go. We've got the IP address from DigitalOcean, and Nginx is up and running. So,
cool.
And as you'd expect, if you delete the application, we go and clean up after ourselves. If you remove it, we'll go and tell DigitalOcean, go and delete the volume, go and delete the load balancer, and it'll go and clean up after itself as well. So, it's all legit here.
All right. You ready for the hard question?
Go on.
Does Portainer provide any convenience around custom resources?
CRDs not yet. So if you are installing operators, you can install them using Helm charts. But no, we don't currently have any native support for CRDs. In all honesty, though, most CRDs are either available as a manifest that you can install, just add application, create from manifest, and even paste in a operator YAML if you need to.
Yeah, what I was thinking was, like, I wonder if, because once you apply the CRD to the cluster, you have this open API spec available over the API. Like, if Portainer could consume that and then give me a web form for those fields based on the open API spec, that would be a pretty cool feature.
Not yet, but happy to take that.
Failing issue.
Happy to take a feature request. Absolutely. Anything that actually makes it easier to consume, absolutely. It's really funny. Like we added Helm support, pushed Helm support out, and Helm is a very cool tool, right? It makes it very easy to deploy stuff, but you still need to know how to modify the values.yaml file. So we make it really easy to edit the values.yaml directly inside Portainer, so you can edit it directly and deploy. It's really funny. We actually released this feature, and then we got commentary back. Why are you actually releasing features for Helm? Helm's dead. It's now all about customize. It's like, what? It's like this environment changes so quickly. So anyway,
Helm is not dead. Helm is definitely
not dead. Helm is so easy. So you can see here's the values file. You can make changes to the values file, hit deploy, and we'll go and deploy it into the cluster. So it makes it really, really easy to work with Helm as well. You can add other Helm repos should you need to. So
Nice.
it makes it nice and easy.
So you're logged into Portainer right now. What sign-on mechanism is used for this instance that we're looking at today?
This one, if I go to settings, authentication, is using local or internal, just because it's my demo environment. But there's absolutely nothing. And by the way, you can change your password characters if you want. We got some beat ups for trying to enforce good practices for passwords. So we made it flexible, because so some people want a password length of 1 character. In fact, some people want a password length of 0. So that this one uses internal. In all honesty, in production, I would strongly recommend something like OAuth.
Yeah.
Because if you do OAuth, you've got things like single sign-on that you can do, automatic user provisioning, automatic team mapping. So if users are in a team, or sorry, in a group in OAuth, we will automatically associate them to a team inside Portainer. So it makes it really easy for management. You don't manage users in Portainer or teams at that point anymore. It's all managed upstream. So in all honesty, you would use one of these primary providers, and it's pretty easy to go and configure against the primary providers in this regard. So
All
I
right.
probably should change my demo to actually use something a bit more reliable.
All right, no worries.
We have things like authentication logs, so you can see who has tried to log into the environment, and when they have logged in, what have they done. So this is a audit log. There's no delete button. There's no purge. We keep this log for 7 days and cycle it. So your CISO can log in and see who caused the outage at 2 in the morning and what do they do. So you come in here and inspect the payload and see what was sent to the backend cluster. So that sits here in a really nice, auditable way. This is the paid version I'm using, by the way, not the free version. So there's a few more features in here. Registries, providing access to registries is quite a burden. So we let the administrator define registries here. So you can add a registry, and once you add registries in here, you can come into a cluster and say, I want to enable this cluster to use this registry, and then I want these users in this cluster or this namespace to have access to it, and then we'll actually propagate the image pull secret into the namespace automatically for you, so your dev users don't need to worry about it. So it makes it nice and easy to work with private registries. And if you so desired, because we're getting a lot of people ask for it, you can actually hide access to Docker Hub. So we actually hide it from the UI, so people can't see the public Docker Hub registry.
Cool.
So just a lot of really interesting features there.
We have another question for Russell, who is asking, is there anything like alerting, or would you expect people to manage them through other tools? I'm assuming that being if a pod is crash loop back-offing, is there a way to kind of alert that for someone?
So we make it obvious in the UI. So in the UI, we make it obvious that it's failing. Like you can see here, this is healthy. If there is a 0 of 1, this goes bright red to show you that there's a problem. That's not alerting, but it's making it there's a visual cue. By the way, this green dot here is if you are using an image. So the green means the image that is running is the same version as the image that's in the registry. If they differ, this little green dot goes red, just as a complete tangent there. So there's no native alerting per se in Portainer, but what we are actually doing is integrating with a product called Sosivo, SOSIV.io. So Portainer is building, or has built, and will be releasing imminently, a native integration with Sosivo. And when you inside a cluster, you will be able to turn on Sosivo monitoring. We will deploy the Sosivo collectors. In fact, if you notice, there's probably a namespace called Sosivo in here because I've been playing around with it. You can actually turn on Sosivo alerting, and it does all of that really cool stuff. Sosivo is what Prometheus and Grafana should be. The reason why we've decided to partner with Sosivo is they share a very similar ethos to us. If you have a wall of metrics from Prometheus and Grafana, unless you know what you're looking at, the metrics are relatively meaningless. Sosivo ingests the metrics, has a whole rules engine inside it, and says this means that. So rather than just giving a wall of metrics, it says, hey, there's a problem with the cluster. This is the problem, and this is what you should do to fix it. So I kind of really like that ease of access to true observability. You can still see the raw data if you want, but they spend a lot of time building the front end, and so we're going to pull all of that information into Portainer and that you see it, but also you can set alerts. So right now you can't, but Civ.io, these guys. By the way, absolutely no commercial relationship with these guys at all. Just like their product and want to integrate with them. So pretty cool. So no native alerting, but once we have the Kosovo integration, we will be able to do that. Yes.
All right, cool.
Other questions?
What's the custom templates thing? Did we look at that?
Custom templates are awesome. And in fact, I probably should have talked about them sooner. So Portainer's goal is to enable those who need to be enabled. So even inside an organization, right? So let's say that you're a company, and the company has the luxury of being able to hire one person who knows about Kubernetes. That one person can actually go and set up a bunch of stuff for the less empowered members of their team. I'm choosing my words carefully here. And so an expert user could come in here and say, I'm actually going to go and create a bunch of templates, which could be, they're all manifest based. It could be, you might paste in a manifest that defines an ingress. You might paste in a manifest that deploys an application with a whole bunch of mustache variables. You can basically add manifests in here and save them as a template that then other users can go and consume. Click deploy, click deploy, click deploy. So it's a very, very simple and easy way to consume advanced capability that an expert inside your organization has created for you. So really nice way to share things. Similar concept, by the way, with the namespaces. When I said the ingress controllers, right? You may say, the expert person will say, I'm actually, we only own the domain, testdomain.com. So I'm going to only allow users to request that. And so once this is done, when users inside the namespace go to create a service of type ingress, the only drop down are the domains that the expert has pre-authorized or pre-validated. So a user can't go and create some random domain and push it out. So we try to make it really easy. So again, custom templates are a way to share things. And so as a user, I can actually go and deploy this. So I can come into this one here, and I can see, for example, I've got a bunch of stuff in here. This is a PVC claim, deploys an Nginx. So there's a bunch of things in here, and I can go and deploy the thing from here pretty quick and easy.
Cool.
So it's just shared. So does that make sense?
Yeah, it does make sense, definitely. Especially for those things, people like to think their Kubernetes deployments are unicorns and super unique, but actually deploying most applications to Kubernetes can be templated relatively easy. Like we all just need to specify a container image and a port and maybe some like CPU limits. Like nothing really is that special or unique.
Yeah, especially when you're using variables. So inside the variable, you can actually put in just basic mustache variables, and then basically when you go to deploy, you can there's a nice input box here, and you can actually replace the variables at deploy time. So it makes them able to be reused in a really simple way. So it's just a nice easy way to say, I'm one expert in my team. I'm one person. I can only work so many hours in a day. I need to make myself infinitely more efficient or effective by propagating my knowledge through to other members of my team through things like templates. And that's kind of the goal. So even though I said Portainer is a tool that almost always an expert might shy away from, an actual true expert realizes the infinite time savings that it's going to make, and say, actually, you know what? I'm sick of getting dumb questions from my colleagues. I'm going to put Portainer in here and actually provide a means to abstract away stuff that I get asked all the time as base templates. So a true expert might say, you know what, this is actually really interesting. I can now get back 5 hours of my day. I'm not answering dumb questions, building templated manifests.
Cool. Are there any other features you want? Sorry, on you go.
No, one of the most important things is dark mode. Everyone wants dark mode. So if I don't click it, if someone will ask, is there a dark mode? Yes, there's a dark mode. I prefer light mode, but there is a dark mode. There's also a high contrast mode for visually impaired, but um, you can choose to do this. So we have API tokens. If you have automation, external automation, you can add API tokens, and then you can automate Portainer. By the way, we're an API first product. Everything in the front end has an API, and you can control it through API.
Very cool. Yeah, it's weird how we went through this phase where like the biggest complaint people had about any bit of software was it didn't have dark mode yet, and it's like I just seen it for every like even random products that were just you just why is that your complaint? Like it just makes no sense. So that's just where we are now.
It is. We haven't talked about Edge, and I probably won't in any depth, but Edge lets us manage Edge devices. Edge devices are simply devices out there on the public internet or out there across the other end of a very, very slow WAN connection. Call it what you like. They're devices that are not in the data center. In fact, they're very far away from the data center. We have the ability to group them, so we can group them based on whatever makes sense for you, either manual grouping or dynamic grouping. And then you can go and deploy a manifest or a Nomad job or a compose file against a group, and Portainer will then go and say, hey, all of the devices in that group, go and run this application and make sure it stays running. So it's a way to actually say, take this application, go and deploy it 1,000 times, 10,000 times, whatever you want, to all these devices, go do it. And if it fails, tell me. But basically just keep trying until it works. So it's a really nice way to centrally manage the deployment of applications en masse. You can also run Edge jobs, which lets you run commands on the remote node directly. So you could do things like df and pull and anything you like to it. So you can go run things on remote devices, and they're basically just bash scripts that run.
I guess I could use that if I had like 3 Kubernetes clusters, one in Asia, one in Europe, one in the US, and I wanted to replicate all the workloads across them. Would I use
100%? You could use it for that. Yeah, 100%. And
I know it's not
you
real
basically
Edge,
say,
but still, I
no,
think a use case I would have at least.
100%. Right now, where the feature is called Edge, it really should just be called multi-cluster management or multi-device management. But right now, it's just Edge stacks, just because it makes sense.
Yeah.
So yeah, it's a very, very powerful tool, and I can spend days going through every feature because we've built something that is just monster. There's so many features, so many capabilities of the product. It's near limitless in its power. I am near useless in front of a kubectl command prompt. I just don't know how to do anything because I don't need to. I just do everything in Portainer. I've forgotten all the commands. But you could set me any kind of challenge. You could say, hey, Neil, go deploy this application like this, and I'd be able to do it in Portainer. There's very, very few examples where I couldn't do something using Portainer, and I'd be forced to go back to a command line.
Sweet. All right. Are we done with the demo? Is there anything else you would like to show before we finish up?
No, we can stop there.
All right. Yeah, there was a lot to cover there. I like the simplicity that Portainer brings to Kubernetes clusters, but even more special than that is that it's not restricted to Kubernetes clusters. We don't play with Nomad, but we've seen the option pop up a few times. There was the Docker Compose stuff. It's like Portainer is a management interface for kind of universal containers, and I like that approach. I think it's going to empower and enable many people, as I'm sure already is. You said there's like over 700,000 active users or something like that. So
every month.
That is a staggering number, but it's very good to see. So we got a couple sorry, and you go.
Let's say we definitely see people who are net new to containers making a start with Docker and then over time transitioning to Kubernetes. And so we really do help them with that process. They can learn how to use it, learn about microservices, learn about triaging microservices in Portainer, and then when they're ready, then we're with them as they make the jump to Kubernetes. A lot of the other tooling out there is only Kubernetes, and you have no choice to go from 0 to 1,000 with and it's like if you're not ready, good luck to you. You got some serious headwinds ahead of you. Whereas Portainer really tries to say, well, actually, you know what, we can actually crawl before we walk, before we run. we're kind of guiding people on what I'd determine a relatively sensible progression from no knowledge to advanced knowledge.
Awesome. A noble and good mission. We have some thank yous in the chat. So Russell and Marat both say thank you, really nice demo, and thank you again. So I will echo their statements. Thank you, Neil, for joining us, for guiding us through Portainer. Before we finish, is there anything you can share about Portainer's roadmap? Anything you're excited about for the next 3 to 6 months? Anything you want to share with our audience before we finish
up? We just launched a new website. Go have a look at it. It is lean, mean, and clean. Inside there, we have a home and student offer. So right now, if you're not aware, we have Portainer CE, the open source version. We have Portainer Business, the closed source licensed version. We make our closed source, the closed source version available for free for anyone who has under 5 nodes in their cluster, right? So anyone with under 5 nodes can go and get a license for Portainer Business right now and use it. And I would strongly recommend if you have under 5 nodes, use that version rather than CE version. You get a lot more capability. If you are a home user or student user and you have more than 5 nodes, we have a home and student license, $249 a year. Go buy that. We give you 15 nodes. You can do everything you want. So for those of us who like to tinker at home, myself included, go and use Portainer Business in your home setting, learn about all of its rich capabilities. You'll love it. And if you're more than 5 nodes, it's relatively inexpensive to get a 15-node environment. There's a free trial available if you have a much larger use case in that, but it's very, very simple and easy to get going. Roadmap, we're looking at things like that front-end form-based wizard that we had there, that actually direct deploys. One of the things we're going to do is try and use that front-end form as a YAML generator and then push the resultant YAML to a Git repo and then allow you to deploy from the Git repo. So it's going to be a cluster context-aware YAML generator. So you can actually use it to generate YAML. That's just quite interesting. One of the things I didn't show you is we have the ability in Portainer to actually create Kubernetes clusters natively from within Portainer. Oh. So you can go into environments, add environment, CAS, and then put your credentials for any cloud provider, and we'll spin you up a CAS cluster. We're adding support for micro K8s for on-prem there as well. And that will also transition to be more as code based. So yeah, there's a lot of stuff coming for Portainer, but we're really focused on making it super easy to use. So everything we do, the number one rule in our product team is, can we make it easier? And if the answer is yes, then we keep iterating our product ideas until we can make it easier.
Awesome. Well, that's a pretty solid roadmap. I'm excited to see all those things coming soon. And I'll say thank you again for joining me. It's been an absolute pleasure. And hopefully we'll do another one of these again soon. So thank you very much, Neil.
All good. Appreciate it.
Thank you all for watching. Have a great day, and we'll see you next time. Bye.
See you all.